So I'm going to go over the 2021 performance exam final review. Okay, so half your points on this performance exam are going to be from getting the correct answer and showing all the work, and half the points are going to be from the explanation. So you have to type out how you did the problems if you want all the points. Otherwise, you're going to end up with a 50 or below. Okay, so this says solve for x and check for extraneous solutions. So when I do this, I'm going to actually rewrite the equation. And I'm going to square both sides here, okay? Because that's how I get rid of a square root. So you're going to say I get rid of the square root by squaring both sides. And then I'm going to have 5x plus 1 over here, and that equals 64. Going to subtract 1 from both sides. That gives me 5x equals 63. And then I'm going to divide both sides by 5. So x is equal to 12.6. It says to check for extraneous solutions, so I want to plug this back in. So I'm going to do 5 times 12.6 plus 1 and see if that equals 8. Well, this is going to be 63 plus 1 equals 8. So yes, that's 64. Square root of 64 is 8. So 8 equals 8. So it did check out. And you should do this anyway just to make sure you got the right answer, okay? So then our next one, same thing, going to rewrite the problem. 7x plus 4 is equal to 11 square root of 3. Going to square both sides because that's how I get rid of a square root. So that leaves me 7x plus 4 over here. And remember, we're going to apply that square to both of these terms. So I'm going to have 11 squared times 3. Remember, when we square square root, it gets rid of the square root. So I'm going to keep simplifying over here. So that 7x plus 4 is equal to 121 times 3. 7x plus 4 is equal to 363. Now I'm going to subtract 4 from both sides. So 7x is equal to 359. Then I'm going to divide both sides by 7. So x is equal to 51.29. And once again, I'm going to plug it back up in there. So I'm going to do 7 times 51.29 plus 4, and does that equal 11 square root of 3? So here again, this is going to be the square root of 3, what did I get? 59, and it's 0.03, but we're going to round it to just a whole number, so that's going to end up being the square root of 363 is equal to 11 square root of 3. And do you remember over here where we had 363 and that equaled this and so on and so forth? So yes, this is going to end up being the square root of 121 times the square root of 3, which is what? 11 square root of 3. So that one checks out as well. Number 3, now this one again, going to rewrite the problem. So this is going to be 9 square root of 2x equals 27 square root of 10. Now I notice that 9 is a factor of 27, so I'm going to divide both sides by 9 to reduce this first. Now you don't have to do this, but it's going to make the problem a little easier. So when I do that, I still get the square root of 2x over here, and I get 3 square root of 10 over here because 9 goes into 27 3 times. Now once again, we're going to square both sides. And so when I square square root, I get what was under there. Remember again, this is going to be 3 squared, right? And then that's going to be 10. So this is going to be 2x equals 9 times 10. So 2x is equal to 90. Divide both sides by the 2. So x is equal to 45. Again, we're going to plug that back up in there. So 9, and we got the square root of 45 times 2, right? 2 times 45. And that's equal to 27 square root of 10. So this is going to be 9 square root of 90. 27 square root of 10. Well, we know that 9 is a factor and it's perfect square. So we're going to do 9, the square root of 9, and then the square root of 10 over here to simplify it. So this is going to be 9 times 3 square root of 10. So, whoops, sorry. I was jumping ahead in my head, guys. So 9 times 3 is 27 square root of 10, and so that's 27 square root of 10. So once again, it checks out. So that is the correct answer, and that's the way we check and make sure that's not an extraneous solution. So our next one, I'm going to change this into a log, and hopefully you guys remember that when we have a base, it stays our base, right? So the log base 8 of 1 over 64 equals x. So this is how we change it into log form. And now we're going to use the change of base formula. So we're going to say the log of 1 over 64, and remember the base stays in the base here, is divided by the log of 8. Now you can do this right in your calculator. And that's going to be equal to x. So x is going to be equal to -2. And again, you can plug it back up in there. If you do x to the -2, you should see that that is 1 over 64. So you can check this. All right, so this one, on this one, I'm not going to use the log. I'm just going to actually take both of these sides to the 1/6 power. So 729 is equal to x to the 6th. The way I get rid of a 6 is to take it to the 1/6 power. So I'm going to do that to both sides. And when I do that in my calculator, we're going to do it 729 caret to the 1 divided by 6, okay? And that's going to be equal to x, because these two are going to cancel each other out. So when we do that, 3 is equal to x. So once again, if you do 729 is equal to 3 to the 6th, you will see that 729 actually equals 729. And they check out. All right, on this one, now this one's a little different. So I'm going to, I know that both of these have a factor of 5. So I know that 5 to the 3rd is 125. And I know that 5 to the 2nd is 25. I'm trying to get the same base here, y'all. That's the objective, okay? And then once I have the same base, then I can just set what's up here equal to each other. So I can set this equal to this once I have the same base. So I can say 3 is equal to 2 times 2x minus 4. So that's 3 is equal to 4x minus 8. Then I'm going to add 8 to both sides. So that's 11 is equal to 4x. I'm going to divide both sides by 4. And recall, guys, everything I'm saying is what you need to write, okay? So that's going to be 2.75. And again, I can plug this back up in there, and I can do 125 is equal to 25 to the 2 times, here, let's just do it with a parenthesis, 2 times, okay, pen, 2.75 minus 4, so this is going to be 125 is equal to 25, 2.75 times 2 times 2 equals 5.5. So this is 5.5 minus 4, right? So that's 125 equals 25 to the what? 1.5 power. So if you take 25 to the 1.5 power, guess what you get? 125. So here again, we can check these. So make sure you guys are doing that so you get the right answer. Okay, on this one, so now we're going to, what number are we on? Number 7. Okay, so here again, we're going to write this. Now we're going to take it from logarithm to exponential form. So this is going to be, we're going to take our base, which is x, and to the 8th power, and that's going to equal 256. Now this should look like the problem we just did a second ago, right? So we're going to take both of these to the 1/8 power. That's going to cross that out. So x is equal to 256, caret again to the 1 divided by 8 power. And when we do that, we're going to get that x is equal to 2. So then in your calculator, you can actually do log base 2 of 256 is equal to 8, right? So that you can check it a couple ways. You can say log of 256 divided by the log of 2, that should equal 8, right? Okay. Or you can put it in exponential form. All right, number 8. This time again, we're going to change it into exponential form. So we're going to take our base, which is 3, and to this power, to the 5th power, and that equals our x. So 3 to the 5th is 343, and that equals x. Okay? So here again, to check it, you could say the log base 3 of 343 equals 5, right? So you could say log of 343 divided by the log of 3, and that should equal 5. All right, number 9. So this time I'm just going to use a change of base formula for this one. So I'm going to say the log of 64 divided by, remember the base stays in the base, y'all, divided by 4. And when I get that, I get 3. Okay? And we know that 4 to the third equals 64. That's another way to check it. We change it to an exponential form. That would be 64 equals 64. All right, number 10 says use the empirical rule if a data set has a mean of, so the empirical rule is when we draw our curve, right? So in the middle is our mean, which is 55. And then we have sigma away. So this is plus sigma, this is minus sigma, right? So that's going to be plus 9 and minus 9. So that's going to get me to 64 here, and it's going to get me to 46 here. And if I kept going, plus 2 sigma minus 2 sigma plus 3 sigma minus 3 sigma. Okay, so if I keep doing that, remember that's 3 times and 2 times the 9. Okay, so this would have been 73. This would have been 82 out here. And then over here, we would have had 37 and 28. Okay. So now we're going to talk about the percentages, right? This was 34%. This was 34%. This one, and these percentages are always the same, y'all, when we're doing these, okay? So that's 13.5%, 13.5% here. Then we've got 2.35% here and 0.15% out here, 2.35% here, and 0.15% out here. So now it's asking us between 46 and 64, right? That's what it's asking us, that range right there. So we got to add the 34 plus the 34, and that's going to be equal to 68%. Now, if it gave us a different number range, like it said 37 to 64, then we would have to add the 13.5 to that. If it said 28 to 82, then we would add 2.35 plus 13.5 plus 34 plus 34 plus 13.5 plus 2.35. Or you could subtract 0.15 times 2 from 100, okay? But so you need to read the question because they're not all going to be 68%, okay? Now this next one has to do with using a calculator. Now we're going to talk about how to do this. So when we do this, you're going to, in your calculator, you're going to do second, then you're going to click the vars button, which is over there. It's 3 down and 4 to the right, okay? And then you're going to click number 2, which is normal CDF, okay? So I'm going to show you all this on the calculator. So recall when we're doing these that we are going to look at the lower bound, the upper bound, and then mu, which is the standard, or which is the mean, and standard deviation, okay? Also recall when we have, these are the things we're looking for. So we're going to look for the lower bound. Okay, pen. This is going to be my day. So we're going to look for lower bound, upper bound, and mu, you know, remember, is the mean. And then we're going to look for standard deviation. So I'm going to put ST. Okay, those are the things that we're going to put in. So we're going to look at this first problem. It says the probability that X is at least 360. So I like to do it this way. So we got from over here to 360, right? And then it says at least 360. So it means we're going that direction, right? So at least means this is going to be our lower bound is going to be 360. And then our upper bound, if we don't have an upper bound, is going to be 1,000,000, okay? It's really infinity, but that's really hard to put in the calculator, so we're actually just going to put for our upper bound 1 million. Okay. And so I'm going to show you guys how to put this both in the calculator and in the program that's on the computer. So here's our calculator, and we're going to go to second and over here to the vars button, and then we're going to choose this 2 right here. So we're going to do 2, enter. That's going to take us here. So we're going to go ahead and put in that lower bound and that upper bound that we just had. So our lower bound, let's clear this out. So lower bound was 360, and then our upper bound is 1 million, and I don't know what number that is right there, so I'm going to go and clear this out too. And you can just put a really big number, guys, but I'm going to put 1 million, and then our mu here, remember, was our mean, and that's 350, and then our standard deviation is 54. Okay. So then we're going to push enter, enter, and notice how this gives us all the terms that we just entered. So that was our lower bound, that's our upper bound, that is our standard deviation, our mu, and that's our standard deviation. Then we're going to push enter again, and it's going to give us this value. So we get 0.4265, right? So that would be 0.427, okay? So now I'm also going to show this to you with the statistics calculator on as a program, okay? So you can also go to this website, which is called statisticshelper.com, and do normal distribution calculator. And when you do that, again, we're going to go in here, we're going to do the same thing again. We're going to put, so it has a lower bound here, see what it says? So here we're going to put 360 again, and then here we're going to put our 1 million, 1 with 6 zeros. Then we're going to put our mean, which was 350, and then we're going to put our standard deviation, which was 54. And then we're going to click calculate, and then it's going to, we're going to scroll back up here, and notice it gives us the same number we had before, okay? And then remember, when we write our answer for this, we're going to write it as a probability, which is the decimal, and we're also going to do it as the percentage. So let me go back here into our screen where we were. Okay. So then that means the answer to this particular problem, when we put in lower bound, upper bound, and remember we had our mean, which was 350, right? And we had our standard deviation, which was 54. Okay. So those are all the values we're going to put in, and then the answer we got was 0.04, sorry, not 0.427, which would be 42.7%. Okay, so the next problem says probability that x is no more than 295. So here, this again, I'm going from 0 up to 295, right? So that's no more than. So that means we got a lower bound this time of negative 1 million. Okay, that's what we're going to put in. And then our upper bound is going to be the one we just got, 295. Remember that mu is the same as it was before. That's going to be our 350. That's our mean. And our standard deviation is going to be 54. So once again, when we put that in the calculator, we're going to get 0.154, or you could say it is 15.4%. Okay. Then between's always easy to me, because with betweens we can literally say lower bound is our smaller number, which is 300. Our upper bound is the 400. And again, mu is our 350. Our standard deviation is 54. Okay, so put all those in there, and then when you do that, this one gives you 0.646 or 64.6%. Let's keep going here. So then we've got that the probability is less than 375. Okay, so if it's less than 375, we got 375 here, and we're talking about everything down there. So our lower bound, again, is going to be minus 1,000,000, right? And then our upper bound is going to be that 375. Mu and standard deviation are going to stay the same. So for D, our answer is going to be 0.678 or 67.8%. All right, so this next one says that it's going to be greater than. So we got our 389 here, and that's our starting point, and we're going to go that direction, right? So this time our lower bound is going to be the 389, and our upper bound is going to be 1,000,000. Again, remember, we're doing the million instead of infinity because it's easier to put in the calculator. Mu and standard deviation are the same. So this time, this answer is going to be 0.235, or, remember, we're moving the decimal place 2 places to the right, 23.5%, which means you could multiply it by 100, guys, okay? All right, so then this last one down here, again, we got our lower bound right here and our upper bound right there. So this, again, is easier, to me, anyway. So then when we do this one, we get 0.483, or 48.3%, okay? So again, when you're talking about this, tell me how you're putting it in the calculator. What are you putting in for the lower bound? What are you putting in for the upper bound? What is your standard deviation and what is your mean, okay? That's what you're going to need to tell me when you're answering this question on the performance final, okay? So Unit 11. So this is determine the study, if the study below should be observational studies or experiments, and why, and how you would set up the observational study or experiment. So the math department wants to know the effects that a calculator has on the time it takes to complete a math test. So would you do this as an observational study or as an experiment? I would do it as an experiment, and what I would do is I would have two groups. I would break the people up into two groups, and then I would do half with a calculator, and I would do half without a calculator. And then I would compare the outcomes, right? Okay? And the next one says the police want to know if the homes that have more than 2 teenagers lead to more car accidents among teens. So would you make this an observational study or an experiment? Yep, I would make it observational. Why? Because obviously, first of all, the term accident in and of itself means that you can't control the outcome. And if you're doing something that causes accidents, that would be unethical, right? So this would be an observational study. So how would you set it up? Okay, so basically you would look at teens that have 2 or more at their house. And then, so you do half that have teens that have 2 or more, and then you do half that don't. And you would compare how many accidents they have. And I would do a pretty big number of these, okay?